It's Monday morning. Sarah, a junior developer, pushes code to production that breaks the entire payment system. The culprit, AI-generated code she trusted without understanding. Today we're diving deep into the AI coding assistant revolution and asking, are we creating better developers or just faster code factories?
Sam, I've been using GitHub Copilot for 8 months now. That incident you mentioned, it happened because I accepted Copilot's suggestion for database connection handling without understanding it was creating a memory leak. I felt like I was productive, but I was just copy-pasting my way to disaster.
Sarah's story isn't unique. We're seeing a 41% increase in bugs when developers use AI coding assistants, according to Uplevel's study of 800 developers. That's not a typo. AI-generated code is introducing more problems than it's solving.
But Marcus, that contradicts other research. Microsoft's study of 4,800 developers across 3 Fortune 100 companies found a 26% productivity increase with GitHub Copilot. Junior developers saw gains of 21% to 40%. We're looking at conflicting data here.
The conflicting studies reveal the real issue. We're measuring productivity by lines of code written, not code quality or long-term maintainability. GitClear's analysis of 211 million lines of code shows AI is creating a technical debt tsunami.
So we have 97% of developers using AI coding tools, according to GitHub's 2024 survey, but wildly different outcomes. Let's dig into what's actually happening in the trenches of software development.
When I started, I thought Copilot was like having a senior developer mentor sitting next to me. It would suggest entire functions, complete with error handling. I felt incredibly productive. I was shipping features faster than my peers.
That's exactly the problem. Sarah was conflating speed with skill. She was writing more code, but she wasn't learning the underlying principles. When that database connection code failed under load, she had no idea how to debug it.
The research shows this disparity clearly. Senior developers with 10+ years experience see modest 7 to 16% productivity gains from AI tools. But junior developers see 21 to 40% increases. The question is, are we accelerating their learning or masking their ignorance?
I was definitely masking my ignorance. I'd ask Copilot to generate a sorting algorithm and it would produce something that worked in my tests. But I never learned why that algorithm was appropriate, what its time complexity was, or when it might fail.
This is creating what some call the junior developer extinction event. Why hire entry-level programmers when AI can write basic code? But companies are discovering they need those junior developers to eventually become senior developers.
Exactly. We're seeing a hollowing out of the middle. Companies want AI to do junior work and senior developers to oversee everything. But who's going to train the next generation of senior developers if there are no junior roles?
Let's examine a specific incident. Sarah, walk us through that production failure. What exactly happened?
I was tasked with optimizing our user authentication service. Copilot suggested replacing our connection pooling with direct database connections for better performance. The code looked clean, passed all tests, and deployed successfully.
The code worked fine under normal load. But during peak traffic, those direct connections weren't being released properly. We went from 50 healthy connections to 847 idle connections in 30 minutes. The database became completely unresponsive.
This illustrates a fundamental limitation of current AI coding assistants. They're trained on patterns that work but lack understanding of production constraints, scaling considerations, or failure modes. The AI optimized for code simplicity, not system reliability.
The worst part, I defended the code during code review because Copilot had generated it with such confidence. I said the AI suggested this approach for better performance, as if that was a valid technical argument.
Sarah's experience reflects a broader pattern. GitClear's data shows code churn, code that gets discarded within 2 weeks, has doubled in 2024. AI is helping developers write code faster, but much of it is throwaway code.
We spent 18 hours fixing that incident. The irony, a senior developer would have immediately recognized the connection pooling anti-pattern. The AI productivity gain cost us 3 weeks of engineering time.
Dr. Rodriguez, the research shows mixed results. How do we reconcile studies showing 26% productivity gains with reports of 41% more bugs?
The studies are measuring different things. Microsoft's research focused on pull requests completed and code compilation frequency. Uplevel measured merge time and bug rates. It's possible to write more code faster while introducing more defects.
The productivity paradox is real. Developers feel more productive because they're generating code quickly. But if that code requires extensive debugging, refactoring, or causes production incidents, the net productivity is negative.
I felt incredibly productive until that production incident. Then I realized I'd been building a house of cards. Fast to build, expensive to maintain, and catastrophic when it collapses.
We're seeing what I call AI-induced technical debt. Code that works initially, but becomes unmaintainable because the developer didn't understand the design decisions. GitClear found a 4x increase in code cloning, copy-paste programming at scale.
Let's talk about the human psychology aspect. Sarah, how did using AI change your relationship with coding?
It was addictive. The instant gratification of getting working code made me impatient with the slower process of actually learning. Why struggle through documentation when AI could just give me the answer?
This aligns with research on skill acquisition. The assistance paradox shows that tools that make tasks easier can actually impede learning. Programmers need to struggle with problems to develop deep understanding.
We're creating what some call vibe coding developers who can prompt AI to generate code but can't actually program. They're productive in the short term, but fragile when AI suggestions fail.
That's exactly what happened to me. I could get Copilot to generate complex functions, but when they broke, I was lost. I couldn't debug code I didn't understand because I hadn't written it myself.
The concerning trend is junior developers who can't write basic loops without AI assistance. One developer told me, "I used Copilot for a week. Now I can't write a basic loop without second-guessing myself."
Let's examine the business impact. Alex, what are companies actually seeing in terms of costs and benefits?
The AI coding tools market is projected to reach $27 billion by 2032, but companies are struggling to measure real ROI. They're paying for productivity gains while accumulating technical debt that costs more to fix later.
Our GitHub Copilot licenses cost $19 per developer per month. But that production incident Sarah caused resulted in $240,000 in lost revenue and engineering time. The tool pays for itself if it prevents even one such incident.
McKinsey's research suggests companies can reduce code maintenance costs by 20 to 30% using AI tools properly. But the key word is properly. Most organizations lack the governance frameworks to ensure quality.
The hidden cost is the time senior developers spend reviewing and fixing AI-generated code. Marcus now requires manual review of any code I write, even simple functions. That's not very productive.
HFS Research estimates technical debt costs global 2,000 companies $1.50 to $2 trillion annually. If AI tools are accelerating debt accumulation without proper oversight, the long-term costs could be staggering.
Let's dive into specific examples. Marcus, can you walk us through other incidents you've seen?
Last month, a developer used Copilot to generate user authentication code that looked sophisticated but had a subtle SQL injection vulnerability. The AI had learned this pattern from insecure code in its training data.
Security researchers at SNIKE found that AI coding assistants frequently propagate known vulnerabilities. The models mirror the average quality of their training data, including outdated encryption and weak authentication patterns.
I once asked Copilot to generate password hashing code. It gave me an MD5 implementation that looked professional but was cryptographically broken. I almost shipped it because I trusted the AI's confidence.
Virtue AI's security audit of coding tools found they all occasionally produce insecure code. In one case, an AI tool introduced an arbitrary code execution vulnerability while trying to help optimize performance.
The scariest incident was when a developer used AI to optimize our payment processing logic. The AI removed what it considered redundant transaction verification steps that were actually regulatory compliance requirements.
Dr. Rodriguez, from a research perspective, what are the fundamental limitations of current AI coding assistants?
Current models excel at pattern matching but lack understanding of context, constraints, and consequences. They can generate syntactically correct code, but can't reason about scalability, security, or business logic.
The models are trained on public repositories, which include a lot of tutorial code, proof of concepts, and hobby projects. They're not trained on production-grade, enterprise-scale systems with real constraints.
The AI doesn't understand the difference between code that works in a demo and code that works in production with millions of users, strict performance requirements, and regulatory compliance.
There's also the hallucination problem. Language models can generate plausible-looking code that uses non-existent functions or implements incorrect algorithms. Developers need deep knowledge to spot these errors.
I've seen AI generate code that calls APIs that don't exist, uses deprecated functions that were removed years ago, or implements algorithms incorrectly. The confidence level doesn't correlate with accuracy.
Let's talk about the impact on learning and skill development. Sarah, how has your approach to coding changed since that incident?
I had to essentially relearn programming. I spent 2 months working without any AI assistance, forcing myself to write every line of code from scratch. It was humbling but educational.
Research on human-AI collaboration shows that over-reliance on AI can lead to skill atrophy. It's similar to how GPS navigation reduces our spatial reasoning abilities over time.
The concern is that we're creating a generation of developers who are AI-dependent. They can prompt and edit AI-generated code, but can't build complex systems from first principles.
Now I use AI differently. I write the core logic myself first, then use AI for boilerplate, documentation, and test generation. I treat it like a very smart autocomplete, not a replacement for thinking.
We've implemented AI code review processes. Any AI-generated code gets extra scrutiny. We also require developers to explain the generated code in their own words before we approve it.
What about the economic implications for the industry? Are we seeing changes in hiring patterns?
Definitely. Some companies are reducing junior developer hiring, assuming AI can handle entry-level tasks. But they're discovering they need people who can grow into senior roles eventually.
We're seeing a barbell distribution. High demand for senior developers who can architect systems and oversee AI, but fewer traditional junior roles. The middle is getting squeezed.
3/4 of IT professionals fear AI will make their skills obsolete, according to Pluralsight's survey. But the real risk isn't replacement, it's becoming dependent on AI without developing fundamental skills.
I was lucky to have mentors who helped me recognize my AI dependency. Many junior developers don't realize they're building their careers on a foundation of AI-generated code they don't understand.
The long-term risk is a knowledge gap. In 10 years, who will have the deep systems knowledge to design the next generation of software if everyone learned to program by prompting AI?
Let's examine some success stories. Are there examples of AI coding assistants being used effectively?
Absolutely. Our senior developers use AI effectively for documentation, test generation, and refactoring legacy code. The key is they understand what the AI is doing and can verify the output.
Amazon reported dramatic success using AI to upgrade legacy Java applications, reducing 50 developer days of work to just hours. But this was supervised by experienced engineers who understood the codebase.
The pattern is clear. AI works well for experienced developers who can guide it appropriately. It amplifies expertise rather than replacing it. The problems arise when inexperienced developers use it as a crutch.
I now use AI for tasks where I understand the problem space well. It's great for generating unit tests once I've written the main logic, or for creating boilerplate code following patterns I already know.
We've found AI excellent for migrating between similar technologies, converting jQuery to modern JavaScript, or updating deprecated API calls, but only when the developer understands both the source and target technologies.
What about the cognitive load aspect? How does AI affect how developers think about problems?
Recent EEG studies show that using AI for coding doesn't reduce cognitive load as expected. In some cases, it increases mental effort because developers must formulate good prompts and validate outputs.
When I relied heavily on AI, I stopped thinking about problems deeply. I'd immediately jump to prompting the AI instead of working through the logic myself. It was cognitive outsourcing.
There's a shift from how do I solve this problem to how do I ask AI to solve this problem. That's a fundamentally different skill set, and it's not clear it produces better software engineers.
I've noticed junior developers becoming impatient with debugging. They expect AI to immediately identify problems, but debugging requires methodical thinking and deep system understanding.
The research suggests AI coding assistants work best for known knowns problems with established patterns. They struggle with novel challenges that require creative problem-solving and domain expertise.
Let's talk about quality metrics. How are organizations measuring the impact of AI coding tools?
Most companies track lines of code, pull requests merged, and development velocity. But these metrics don't capture code quality, maintainability, or long-term technical debt accumulation.
We started tracking code churn, how much code gets rewritten within weeks of being committed. AI-assisted commits show significantly higher churn rates, indicating lower initial quality.
GitClear's analysis shows concerning trends: more copy-paste code, less code reuse, and higher rates of bug fixes shortly after commits. The AI is optimizing for speed, not sustainability.
Looking back at my AI-generated code, I can see the patterns. Lots of similar functions instead of reusable modules, verbose implementations instead of elegant solutions, and band-aid fixes instead of proper architecture.
The fundamental issue is that AI coding assistants are trained to complete tasks, not to write maintainable software. They don't understand the difference between working and good.
What about the future? How do you see AI coding assistants evolving?
The next generation will likely have better understanding of code context, security implications, and performance characteristics, but they'll still lack business domain knowledge and long-term architectural vision.
We're seeing the emergence of agentic coding tools that can modify entire code bases autonomously. This could amplify both the benefits and the risks we've discussed today.
I'm optimistic about AI tools becoming better at explaining their suggestions, providing alternatives, and helping developers understand trade-offs. But human judgment will remain essential.
I hope future AI tools focus more on education than automation. Instead of just generating code, they could explain why certain approaches are better and help developers learn underlying principles.
The ideal would be AI that enhances human capabilities rather than replacing them. Tools that help developers think better, not think less.
Let's discuss governance and best practices. What should organizations do to maximize benefits while minimizing risks?
First, treat AI-generated code like code from a junior developer. Mandatory review, testing, and validation. Never assume AI output is production-ready without human oversight.
Organizations need new metrics that go beyond velocity. Track technical debt accumulation, code maintainability scores, and long-term system health, not just development speed.
Implement AI literacy training for developers. They need to understand how these models work, their limitations, and how to prompt them effectively. It's a new skill that requires education.
For junior developers especially, there should be phases of AI-free development to build fundamental skills before introducing AI assistance. You need to understand coding before you can understand AI-generated code.
We've implemented AI pause days, where developers work without assistance to maintain their core skills. It's like athletes training at altitude harder initially, but build strength.
What about the security implications? How are organizations handling AI-generated security vulnerabilities?
Security teams are implementing specialized reviews for AI-generated code. Some organizations require security scanning of all AI-assisted commits before they reach production.
Amazon's Code Whisperer includes built-in security scanning that checks AI suggestions for common vulnerabilities. But this is reactive. It's better to train developers to recognize security anti-patterns in AI output.
We've seen AI suggest outdated encryption methods, weak authentication patterns, and even code that appears to implement security but actually creates vulnerabilities. Security review is non-negotiable.
I learned to always research the security implications of AI-generated code. The AI might generate a function that handles user input, but I need to verify it properly sanitizes and validates that input.
The challenge is that AI security vulnerabilities are often subtle. The code looks professional and might even include comments about security, but implements it incorrectly.
Let's examine the psychological and social aspects. How is AI changing team dynamics and collaboration?
Initially, I felt embarrassed to ask questions because I thought I should be able to figure everything out with AI. It reduced the natural learning conversations that happen between junior and senior developers.
We noticed less pair programming and code discussion. Developers were working more independently, which reduced knowledge transfer and mentoring opportunities. That's problematic for team growth.
Research shows that 60% of developers learn through peer interaction and code review discussions. AI tools can inadvertently reduce these crucial learning moments if not managed carefully.
There's also a confidence issue. Developers who rely heavily on AI may become less confident in their own problem-solving abilities. They start second-guessing decisions they would have made confidently before.
Exactly. I remember feeling anxious when AI suggestions didn't match my initial approach. I'd think the AI must be right instead of trusting my understanding of the problem.
What about the economic pressures? Are companies pushing developers to use AI tools regardless of the quality implications?
Absolutely. With 75% of enterprise developers expected to use AI coding assistants by 2028, according to Gartner, there's pressure to show productivity gains. Companies are optimizing for short-term metrics.
Leadership sees the 26% productivity increase headlines and expects immediate results. They don't always understand the hidden costs of technical debt and increased maintenance burden.
The business pressure creates a mismatch between what executives expect from AI tools and what developers experience in practice. This leads to unrealistic deadlines and quality compromises.
I felt pressure to ship features quickly using AI assistants, even when I wasn't confident about the code quality. The expectation was that AI would make me instantly more productive.
Some companies are reducing development timelines based on assumed AI productivity gains. This creates a vicious cycle where developers feel forced to rely on AI assistants to meet unrealistic deadlines.
Let's talk about different types of AI coding tools. Are some more problematic than others?
The newer agentic tools that can autonomously modify entire codebases are particularly concerning. Unlike autocomplete tools, they can make sweeping changes that are hard to review comprehensively.
We've seen tools like Cursor's AI agent make unintended changes to files that developers didn't even know were modified. One developer had to frantically undo changes that broke their entire project.
Simple autocomplete tools like GitHub Copilot suggestions are easier to verify. But tools that promise to refactor entire applications or implement complex features autonomously carry much higher risks.
I stick to tools that show me exactly what they're suggesting before I accept it. The black box tools that make changes without clear explanations are too risky for me now.
The transparency and explainability of AI suggestions is crucial. Developers need to understand not just what the AI is suggesting, but why it made those choices and what alternatives exist.
What about the environmental and computational costs? Are we considering the broader impact of AI coding assistants?
Each query to models like GPT-4 consumes significant computational resources. If developers are making hundreds of AI queries daily, the collective environmental impact is substantial, but rarely discussed.
The irony is that AI tools might be generating more code overall, much of which gets discarded. We're using massive computational resources to create throwaway code that increases rather than decreases waste.
Our cloud computing costs have increased partly due to AI tool usage, but also because the AI-generated code tends to be less optimized. We're seeing both direct and indirect cost impacts.
I never thought about the environmental cost of my constant AI queries. When I was heavily reliant on Copilot, I was probably making 200+ API calls per day for even simple coding tasks.
Companies are essentially outsourcing computational work to AI providers without considering the total cost of ownership, including environmental impact and long-term technical debt.
Let's discuss specific recommendations. What concrete steps should organizations take?
Implement staged AI adoption. Start with experienced developers using AI for specific tasks, then gradually expand to junior developers with proper mentoring and oversight.
Establish AI coding standards that specify when AI assistance is appropriate, what types of code require human review, and how to validate AI-generated outputs effectively.
Create new performance metrics that account for code quality, maintainability, and long-term system health, not just development velocity. Measure technical debt accumulation alongside productivity gains.
Require junior developers to demonstrate fundamental programming skills before introducing AI tools. They need to be able to code without assistance before they can effectively use AI assistance.
Implement AI circuit breakers. If code quality metrics decline or technical debt increases beyond thresholds, temporarily restrict AI tool usage until the team adjusts their practices.
What about the future of software engineering education? How should we prepare the next generation?
Computer science curricula need to emphasize fundamentals more than ever. Students must understand algorithms, data structures, and system design before learning to work with AI tools.
We need to teach AI literacy alongside programming, how to prompt effectively, validate outputs, understand limitations, and maintain skills independent of AI assistance.
Students should learn to debug and maintain code they didn't write, since AI-generated code often feels foreign. That's a skill that will become increasingly important.
Engineering programs should include coursework on technical debt, code quality metrics, and long-term system maintainability. These concepts become critical when working with AI-generated code.
Most importantly, we need to preserve the intellectual curiosity and problem-solving mindset that makes great engineers. AI should enhance human creativity, not replace it.
As we wrap up, let's get your personal predictions. Where do you see AI coding assistance in 5 years?
The technology will improve dramatically better context understanding, security awareness, and code quality. But human oversight will remain essential for complex system design and architectural decisions.
We'll see market consolidation as organizations realize that not all AI coding tools are equal. Companies will prioritize tools that enhance developer capabilities rather than replace them.
The industry will develop better practices for AI integration. We'll see standardized review processes, quality metrics, and training programs that help developers use AI effectively and safely.
I hope we'll find the right balance AI that makes programming more accessible while still requiring developers to understand what they're building. Technology should amplify human intelligence, not replace it.
The key is maintaining human agency in the development process. AI should be a powerful tool that helps developers think better and build better systems, not a black box that makes decisions for them.
Any final advice for developers and organizations navigating this transition?
Don't let AI become a crutch. Use it to enhance your capabilities, but maintain and develop your fundamental programming skills. You need to be able to think through problems without AI assistance.
Invest in proper training, governance, and quality metrics. AI coding tools can provide tremendous value, but only with appropriate oversight and integration into your development practices.
Focus on long-term sustainability over short-term velocity gains. The productivity increases are real, but they're meaningless if they come at the cost of system maintainability and developer skills.
Stay curious and critical. AI coding assistants are powerful tools, but they're not infallible. Question their suggestions, understand their limitations, and always prioritize human judgment for important decisions.
Sarah, Marcus, Dr. Rodriguez, Alex, thank you for this honest and nuanced discussion about AI coding assistance. You've shown us both the promise and the perils of this technology.
Thanks, Sam. I hope sharing my experience helps other developers avoid the pitfalls I encountered and use AI tools more thoughtfully.
It's been valuable to discuss these challenges openly. The industry needs more honest conversations about the real impacts of AI tools on software development practices.
The research is still evolving, but it's clear that thoughtful integration of AI tools requires careful consideration of both benefits and risks. Human expertise remains irreplaceable.
The future of software development will be shaped by how well we balance AI assistance with human skills development. Getting this right is crucial for the industry's long-term health.
This episode was brought to you by Unstruct AI, creating the most trusted AI news analysis platform, with a focus on the human cost. After all, progress without humanity isn't progress at all. Next week, we'll examine how AI is reshaping the gig economy and whether technological efficiency is coming at the cost of worker dignity and economic stability. Until then, question the shortcuts, value deep understanding, and remember, the fastest code isn't always the best code. This has been Unstruct AI, where we examine technology's human impact.